here's another quadratic equation that I'm going to solve. The problem asks me to find the real or imaginary solution to this equation. 12x squared plus 14x plus 32 equals 32. Now I noticed two things right away about this equation. One, that it has multiple 32s, one on each side of the equation. And then every number is even. So here's what I'm going to start by doing. I'm going to subtract 32 from both sides. That's going to give me 12x squared plus 14x equals 0. Now when I run into a situation where I have an a term, a b term, but no c term, I am going to try and solve by factoring. And the reason for that is I know one of my answers is going to be very, very simple. One of my answers is going to be 0. I can take a greatest common factor of 2x out of this. We've talked about this in classes like undistributed. So when I take 2x out of 12x squared, I'm left with 6x. If I were to re-multiply those together, they would multiply back to 12 and x squared, just like I would hope. The 14x, when I pull 2x out of it, becomes 7. Now remember, we've got an instance of the zero product property here. We're trying to say to ourselves, how would 2x equal 0? Well, that one's pretty simple. X equals 0. And how would 6x plus 7 equal 0? A little bit more complicated. I would subtract 7 from both sides. I would say, how do I make 6x equal -7? Well, I have to divide by 6. And that's going to happen when x equals -7/6. So, because this is something that I can factor, I think that's the simplest way to solve it. If I were to take either one of these answers and plug them back in, they would make the equation true. I'll do the simple one, and I'll let you do the hard one at home. If I make x equal 0, 12x squared becomes 0, 14x becomes 0, and 32, obviously, since there's no x involved, stays as 32. And I get this equation 32 equals 32. Absolutely. All right, you can try at home to plug in -7/6 and see that it still works.